Hi, everyone. Thank you so much for joining us today. On behalf of Stormwater Solutions and our sponsor, EnviroPod, I'd like to welcome you to today's presentation titled Reducing Trash in Our Waterways, Regulatory Challenges and Trash Control BMPs. If anyone has questions throughout the presentation, please click the Q&A box at the bottom of your screen and enter your question. Questions will be addressed at the end of the presentation if time allows. If not, questions will be answered offline. Our speakers for today's Lunch and Learn session are Michael Hanna, Seth Brown, and Chris Summers. And I'll go ahead and turn it over to Will Harris for a quick introduction.
Hi, my name is Will Harris. I'm co-hosting this event. I'm president of Clean Waters USA and working on behalf of EnviroPod International. I want to thank everyone for having registered for attending this event today. And if you go to the next slide, Seth, I'd appreciate it. Briefly, I'm giving an introduction to the speakers and in what order they will be speaking, and this being a rather important topic and rather critical across North America right now. The goal of this webinar is to share insights and knowledge on state and local efforts to control the discharge of trash into local waterways, as well as provide examples of effective trash reduction practices and devices that prevent trash from entering local streams, rivers, and oceans. Today we have Seth Brown, Executive Director from the National Municipal Stormwater Alliance. He'll be speaking on the current state of trash reduction efforts by state and local agencies. Then Seth will hand it over to Chris Summers, environmental scientist with EOA, to talk about the California experience, as I call it, under the California Trash Capture Amendments and MS4 compliance in that state. Michael Hanna will then speak last, and he is a technical director from EnviroPod International, who will focus on providing various examples and critical factors in selecting the right trash control BMP for your project. There will be a short closing remarks, but I want to let everyone to know that if they happen to catch my email, and Seth, maybe go back to the first slide. If you have any questions directly or want to know more about this webinar and how we can enhance this, or if you're interested in having us present to your team at all, you may contact me at the toll-free number listed at the bottom of this slide or email. You can also visit the EnviroPod website at www.enviropod.com. So with that, I'm going to turn it over to Seth Brown, and thank you again for joining us.
All right, thanks, Will. Okay, I'm going to kick things off and get things going here so we can stay on schedule. We got a lot of ground to cover for all of us. First, I wanted to, again, thank, like Will, I want to say thank you for joining us today. I'm going to be talking about the role of the National Municipal Stormwater Alliance and work that we've done in trash reduction and control. We did a survey, and I want to share some of the results of that survey. I also want to talk about some other issues. Before going too far, I did want to give some context about what I'll be covering. I'm going to give some background on NAMSA, talk about some policy issues and regulatory items that have come up. But then I'll really focus on this survey. I'll have a couple takeaways and then talk about industry standards that related to trash capture that we'll be talking about. And as far as Q&A is concerned, we're going to be doing all that at the very end. So, all right. So just real quickly, NAMSA is the National Municipal Stormwater Alliance. For those who aren't aware of who we are, what we do, we are a national coalition. So we're an organization of organizations. We don't have individuals as members. We're the only national organization that focuses specifically on the MS4 sector, the municipal separate storm sewer system sector. A lot of other organizations touch on these issues. We focus entirely on that, and we're really trying to promote MS4 programs as much as we can. And our vision is to help provide clean water by having effective and efficient MS4 programs and provide information so that they can meet those goals. That's where we're coming from. We've got action areas. I'm not going to go through all of this, but you can see that we're pretty diverse. We focus on policy, advocacy, education, communication, and messaging, as well as, of course, sector support for the MS4 sector. We're active in all of these areas. We were launched in 2018, and with a handful of states, and now we're up to half the country. So we have 24 states, with 25th about to join, and we've got several affiliate members as well. We got some individual MS4s as well as some affiliate members, including EnviroPod. We thank them. So, and this is just a quick snapshot of our leadership. Scott Taylor from California, which ties into, I think, with, like the tie-in with what Chris is going to talk about with the trash amendments. We've got Randy Prash from Minnesota, the Minnesota City Stormwater Coalition. I know that Minneapolis is active in the area of trash control, and then James Moore, who's with our Georgia Association. Okay, so I'm gonna get over to the actual topic at hand. I want to focus on just some background information that, that there's a lot of information that is showing the role of, or the significance of the role of MS4 programs, urban areas, land-based sources. All of these are a critical component of how plastics get in the environment, how trash gets in the environment. This just shows that, an estimate of, around 80% of ocean plastics are from land-based sources. And as folks know, who are involved with stormwater programs, a lot of trash, debris, plastics, floatables get clog up our inlets, our BMPs, and whatnot. So we play a critical role in this issue, even though we often hear about what's going on in the ocean, which is important, but we need to start focusing on the land-based sources, go to the heart of the problem. And of course, California is leading the way on this, and we'll hear more about that. I'm not going to steal anyone's thunder on that one. So, but the point is, we play a significant role. MS4s play a significant role here. I wanted to mention NAMSA has been working with something that's called, or a group called the Trash Free Waters Program within EPA, their oceans, their Office of Oceans, Wetlands, and Watersheds, who's been focusing on this. We've been partnered along with the American Chemistry Council's Plastic Division. I had a couple of convenings over the last year. Unfortunately, due to COVID, they were remote. But they were still good. Those are available. If there's any interest in that, let me know, and I can get you some recordings on that. But there's, the EPA released a trash stormwater compendium, how to get trash integrated into MS4 permits. That was released this year. There's also an Office of Inspector General report released in May 2021 as well from EPA, 2 independent documents. Just interesting that this is going on. So this is a rising issue, and we're definitely involved with it. So as part of this effort in this partnership, we led a survey. This was not a statistically significant survey. We would like to do that, but this was something we did as just kind of a short, quick snapshot from the sector to see. Just we want to characterize what's going on in the MS4 world on stormwater and trash. And so we released this out. We had, responses from almost 90 responses, a lot, from the Southeast and the mountain states, but we get them from all over the country. And primarily we get them from phase 2, so small and mid-sized communities, which dominate the MS4 sector in terms of the number. So it makes sense that you'd have more phase 2s, but we also had a significant number of phase 1s and others as well. So that's the backdrop of this survey. I just want to share some of the interesting results we got here. So one of the first questions is this a topic that's significant at all? And, if it's not a significant issue, you're not going to see a lot of action, I think, at the local level. And what we found was that fairly to very significant was dominant. And we had close to 60% of the respondents saying that this fits into this category, with the highest being very significant. So this checks that box on the question is this something even worth getting into? Is there a lot of interest? Is it significant enough of an issue at the local level? And the answer that we got from this survey was yes, it is. The second was we wanted to know about trash capture measurement. What are the metrics used and who's doing this work? So the first was, do you even measure trash capture? And if so, who, or do you measure, do you perform trash capture? Do you measure it? And if you do, who leads this effort? So what we found is about an even split between those who say no and those who say yes. And then we had some that kind of fell in the other category, not sure, or maybe they kind of do, kind of don't, that fell into that other category. But the point is that there's a significant number who do have trash capture programs. And the other thing to notice is that there was not a consensus about who leads this. Is the stormwater program? Is it the solid waste department? Is it a cooperative? Is it something else? So not a lot of consensus there. That's interesting to know. is something that's interesting as a takeaway, I think. We wanted to know, how about metrics? How do you measure that? And again, this is not a consistent thing. In fact, we found that there's an even split between looking at weight, whether that's dry weight or wet weight, volume, or something else. So clearly there's not a consensus in how what the metrics are related to measurement, or metrics related to trash capture. Then we asked, is this, is trash capture part of your MS4 permit? And we see significant, quite a few, almost double of the folks that said yes compared to said no. So most communities have this in their permit. And then the next question is, do you track and report it in your permit? And most said no, we don't. So that's another takeaway, that there's a need to do this, but it's not happening to the degree we can that is needed to track with the permit itself. So that's another interesting takeaway that kind of informs us what the challenges are for the MS4s in stormwater and trash. We also asked about, what are the elements? So is this, where does this land? If you've got a trash control or trash reduction program, where does this land? And not surprisingly, most of the time it's in the public education area. Public education outreach is part of the MCMs that are out there, as far as the minimum control measures. Part of MS4 phase 2 permits is public education outreach and engagement. This checks one of those boxes very well. It's out in the you see litter cleanups, stream cleanups, adopt a road or whatever it is, to adopt a highway. All of those things kind of tie in here. But there's also significant looking at just trash removal from waterways themselves. So this is just primarily saying we need to get this stuff out of our waterways, not just checking the box for public education. It should be noted that you could, respondents could check more than one box in this context. Something that we'd heard as we'd gone along in this effort with EPA in this trash-free waters partnership that we were involved with, was that there was, is trash capture and trash and stormwater issues, is this something that's a solid waste issue, or is it a stormwater issue? And if it's a little bit of both, do solid waste and stormwater programs coordinate well? So that was a premise that we had. This could be a challenge. And sure enough, we asked the question about how coordinated this is between the different departments that might be involved, stormwater groups, or solid waste or others. And it looks like moderate to mildly coordinated kind of dominate here. So there's an opportunity here to try to increase this coordination to have a more effective trash capture, trash reduction at the community level. And we asked, how could, what types of things could help to make that happen, or just help trash capture and reduction generally writ large. And so it's just interesting to note that there was, again, multiple responses available to respondents. But you can see that there are some that stood out more than others. And one is just looking at leadership and having webinars like this, frankly, a community of practice, an online resource. This is all information based. I think folks just want to have more information about how to do this effectively. And I think another thing that's interesting is that there was a significant, actually the most support, or the second most support, was for a crediting system and I know we'll hear about that on the California aspect, but we're looking beyond California as well. If there's a way to capture this and credit this in in permits, then maybe there'd be more support for this. So that's another interesting takeaway, I think. So, okay, so I'm going to wrap up now and just say that some of the major takeaways that we had from this survey is, again, that it's a significant issue. There's this trash in general. I think there's just more awareness overall on plastics and the impact of the environment. So it's being seen as, or it is seen as a significant or very significant issue. Most communities have trash reduction or trash capture in their MS4 permits, but most do not track or report that at the same level, at least. There's a lack of consistency in the metric of how much we capture, weight, volume, pieces, whatever it is. There's a lack of consistency there, and a lack of consistency in who leads this, whether it's trash, or I'm sorry, solid waste or stormwater or some other. So there's not a consensus there or consistency there. There's not a clear consensus on how to address this coordination. There's a lot of different things we can do, but things like this, again, education, outreach, webinars, community practice, those seem to be the ones that resonate the most. And we also see that there's interest, like I said, in a regulatory crediting program to incentivize. So again, if this is going to be something that's written into your permit, if there's a way to have consistent metrics and consistent crediting, there's more support for that as well. So one of the big takeaways here is that there's a need for a broader survey. We want to do that. That's statistically significant. I did want to mention that NAMPS is involved with the new committee for ASTM, the ASTM Committee on Stormwater Control Measures E64. They're developing a trash capture standard right now. It's based upon the Caltrans standard. This is a significant issue. This ties into our stormwater testing program called STEP, which EnviroPod is a supporter of as well. So this is something to look for in the near future. We feel like the standardization is going to help us move forward. And how do we measure performance related to trash capture and reduction? And I think that's it. We're not going to take time to take questions now. So I will stop sharing my screen and I will hand this over to Chris Summers.
Great, thanks, Seth. Let me just get my presentation up here real quick. Okay, I'm Chris Summers. I'm Vice President with EOA Incorporated, and really glad to be here today. I'm coming from Oakland, California. And yeah, I've been on this kind of wild ride of figuring out ways to manage trash and stormwater, measure trash and stormwater and receiving waters, and trying to understand how effective we're being on all the money that's being spent on trying to reduce the impacts, either from a prevention standpoint or from a capture standpoint. And it's been about a 20-year ride so far and still going. My presentation is going to be the California experience over that last 15 years, roughly 20 years, and what kind of where it's going, where we're at, and where it's going. So I'll talk first about kind of the impetus for all this attention, and Seth got into it a little bit, but I'll talk about it from the California perspective, about the levels of trash and the documentation of the levels of trash that are we've been able to see in California surface waters, including the ocean, but also local creeks and rivers. And then in what California has done from a regulatory standpoint, through their water quality planning policies, and also through NPDES stormwater permits, and the establishment of these compliance pathways for stormwater that those policies have enacted. And then I'll get to some lessons learned to date. And so it's hard to get all of this into a 15-minute presentation. So I'll give you some contact info at the end. If you have any additional questions or want additional information, you can contact me. I always like to start with this. This is California's definition of trash or litter. It's in the government code. And it's basically comes down to a broad definition of any improperly discarded material. And it's not just plastic, it could be other materials as well, that's thrown or deposited on land or the waters of the state. And one thing I want you to notice here is that definition of trash doesn't have any size associated with it. So although we've focused mostly, and my talk will be mostly on macro trash, greater than 5 millimeter trash by diameter, obviously there's been a lot of work and exponentially growing on the scientific studies and our understanding of sources and impacts related to microplastics and micro trash that is less than 5 millimeters. So this definition covers that micro trash as well. So I want to kind of take you back to the late 90s, really when this first started to get the attention from a water quality perspective in the state of California. And mostly that happened through documentation, observations, both visual as well as quantitative, of the levels of trash that we were seeing in waterways. And so these are two examples here. One, the lower LA River. This is at a boom that still exists in the lower LA River that drains a very large catchment. Remember, the LA River is for those of you who've seen Grease, where they race the cars in the concrete channels, that was the LA River. That is the LA River. Coyote Creek up in San Jose is a much more natural system, has riparian corridors and down trees and woody debris, and it blocks the transport. This is in San Jose, which is in the South Bay in San Francisco Bay. So the State Water Board and MS4s collectively started collecting data in receiving waters back in the late 90s and into the early 2000s. And it was really pretty alarming, the levels that they were observing. And it was documented that there were impacts to beneficial uses that are established through California Water Code and under the Clean Water Act. And those include wildlife, recreation, navigation as well, where applicable, as well as recreational includes aesthetics, right? So we have not only full body contact recreation for swimming or bathing, beaches, but also Rec 2 beneficial uses, which includes pretty much just enjoying the natural waterways while you're next to them and picnicking by them or hiking next to them. So this trash, not only from a wildlife standpoint, was potentially impactful, but also from a recreational standpoint as well. Super important, especially in the last point, for California beaches. And so this, in the LA region, and in the San Francisco Bay region, these data were used to list waterways in these two regions for impairments on the Clean Water Act 303D list as impaired by trash. And that really started the focus on, well, what are the actions that are actually going to be implemented? What's the program that in California, we have 9 regional boards that oversee water quality and 1 state board that oversees statewide policy. And so these 2 regions started to enact first the TMDL, which I think was possibly the second TMDL in the nation for trash. And that was back in 2008. It was adopted by the LA Regional Board, Water Board. And it established a water quality-based effluent limit for macro trash greater than 5 millimeters in MS4 discharges. And it said basically there can be 0 discharges of trash. And they used the narrative standard to be able to establish this TMDL and the impairment. Soon after, the San Francisco Bay incorporated, without a TMDL, requirements directly into the MS4 NPDES permit. And the MS4s within the Bay Area didn't really fight back on this because they knew that, one, a TMDL would be coming and getting at this sooner than later made the most sense. And obviously there was a lot of data collection that was suggesting that this was problematic. So it was included in the MS4 permit, and it basically said the same thing as the LA River trash TMDL, is that no trash greater than 5 millimeters was allowed in MS4 discharges. Now, we all know that 0 trash is not an accomplishable goal in MS4 discharges. But what the state did is it started to establish, it took a few years after that, but based on these 2 regions' efforts from a policy development standpoint, the state enacted a statewide adoption of amendments to the statewide water quality control plan. And it did 3 things. One, it established a statewide narrative water quality criteria, water quality objective, we call them in California, for trash, which basically said no trash in adverse amounts in waterways. Secondly, it established a discharge prohibition for trash in stormwater and other pathways. So no trash and discharges. And then third, it set if you will, an alternative compliance program. And so it said, hey, instead of doing all these TMDLs on a watershed or water body basis, we're basically saying that all urban waterways throughout the state, and the data supported this, are impacted by trash, and that stormwater discharges are important pathways. And that seems to coincide with, Seth's survey that people are realizing that, actually stormwater discharges are important, and we do have trash issues within our urban waterways that has grown over time. And it also said that all stormwater dischargers can achieve the discharge prohibition by a time certain date of 2030 at the latest. And then they established these compliance pathways, which was really the important part, these alternative compliance pathways. So you can't hit zero in your discharge. What are we going to require you to do so that you're deemed as in compliance with your discharge prohibition? And so they gave two options, and these were the same options that basically were given in the LA region and the San Francisco Bay region. And the first option was really the start of a whole industry of trash capture devices. And so it set a design standard based on data were collected in the LA region that treatment control of or a series of treatment controls that traps all particles that are greater than 5 millimeters, that macro trash definition, that has the design treatment capacity, it's a flow treatment capacity rate resulting from the 1 year, 1 hour storm event. And so that set a standard then that was used to start to certify full capture devices by the State Water Resources Control Board. And today there's over 40 of these devices that are now certified as full capture systems within the state of California. So these are a few of the examples of the tens of thousands, if not hundreds of thousands now, of devices that have gone in California over the course of the last 15 plus years. There's all shapes and sizes. There are end of pipe netting systems. There's inline HDS or hydrodynamic separators. There's inlet-based screening devices and baskets, which I think you'll see a little bit later in the next talk. And then there's screening devices that are inline or at the end of pipe as well. So these are all most are proprietary devices. There is an allowance for they call multi-beneficial systems, which could include green infrastructure, and other systems that are more naturally based. So just I work in the San Francisco Bay Area, so I help a lot of the MS4s throughout the region, just to give you a sense of where we are in Northern California or Central California here. So the San Francisco Bay. There's tens of thousands of acres that now have been treated by these full capture systems and through installation over the course of the last decade. So just to give you an idea of the level of effort we're talking about here, all the blue areas are treatment areas for what is now treated by full capture systems. So it's pretty massive level. I could show you a similar image for the LA region. LA alone has over 50,000 inlet-based devices and a number of other larger systems that they've implemented as well. So significant effort from a capital improvement program and retrofit program. Option two is really everything else. So it could include partially full capture systems to address some of the areas that are considered significant trash generating areas that drain to MS4s. But mostly it includes source controls, including what we call true source controls in California, which is really pollution prevention efforts, as well as institutional source controls, things like street sweeping and online cleanup. And these option two, or what they call track two systems or control measures in the state have to be demonstrated that they are equivalent to the trash reduction that would occur if you were to install a certified full capture system. So the question is, well, how do you measure that? How do you determine that you're equivalent? And they've established a process where you establish a baseline trash levels on land, and then you compare over time as a surrogate for the levels that are getting into stormwater and being discharged. And so these are a few examples of both true source controls and institutional source controls that are out there. There's guidance on this. The state, our state organization, the California Stormwater Quality Association, has developed on the effectiveness of these systems. But the measurement of these systems is really about establishing a baseline, which in the Bay Area, there was a study that established baseline based on probabilistic sampling of a number of sites, and then superimposing those onto land areas based on the modeled results. And as what you can see here is that, you know, the high or very high levels are red or pink on the map, the low levels are green. And what we've been able to do is establish that if you can get to a low trash generation level and document that, then you're seen as full capture equivalent. But these areas that are red, yellow, or purple are really where the actions need to take place, either full capture or equivalent measures, and through monitoring, be able to document that they've hit that low trash generation level. So the one way we do that is through on-land visual trash assessments, which is a protocol we developed. It's now being applied at a statewide level. And these are visual qualitative assessments of street links, street and sidewalks, parking lots, trying to understand the relationship between what's up on land and what gets into the storm drain system. And through that study I showed you, we were able to establish that, yeah, the volume, in this case, we were measuring volume of trash that we were able to measure through the storm drain system, the loading of trash. We were able to establish a relationship with the on-land visual assessment categories. And so you see the green, yellow, red, and purple here in comparison to the volumes that we see. So we use these A, B, C, D scoring to assess the levels over time at selected sites throughout the landscape, and then use those to demonstrate reductions over time. And so the goal here is to get to A scores pretty much everywhere. Obviously a steep task. Lastly, I just wanted to go through kind of, you know, quickly on the lessons learned from the last decade. So, and some of this is consistent with what Seth was mentioning. But you know, trash is pretty much found in all urban waterways at levels that are generally, from a public standpoint or water quality standpoint, considered to be unacceptable. And that's getting better over time, but obviously a difficult thing to measure, given the measuring tools are not exactly quantitative. There are many different types of impacts to beneficial uses, as I mentioned earlier in my talk. And through our work that we've done on receiving water monitoring and the policies have been developed to statewide level, the stormwater pathway itself is important. And I think that, you know, when we talk about land-based sources, stormwater is one of the pathways that gets into receiving waters, but there are also other pathways, which I'll mention here in a second. Through our quantitative studies that we've done through the storm drain system, you know, more than 70% of the trash by volume is made of plastic. And so plastics are kind of where the world is on the levels of trash that we're seeing, and control measures that need to try to reduce the levels of plastic. And obviously we can do that in many different ways. The most cost efficient way is to try to get people to use less plastic and dispose of it or recycle it in the correct ways of the plastic they're using. So there's a lot of focus on true source controls of trying to, you know, do things like single-use plastic bag bans, polystyrene bans for foodware, looking at alternatives to plastics that could be more biodegradable. A lot of work happening at the local level and at the state level on this focus. Secondly, a lot of focus on full capture systems, since it is a kind of a more direct compliance pathway that doesn't require significant ongoing monitoring associated with it, but it does require ongoing maintenance, which is obviously a burden to resource-strapped municipalities. The other is on-land. So we have been able to see on-land visual assessment scores to be increase and get better and get to those A levels based on actions that are happening up on land, street sweeping, on-land cleanups, working with businesses, neighborhood beautification work, building or business improvement districts, things like that. And then I want to, the last two I'll go through is, one is we can't intercept or reduce or prevent all trash. So there will always be an ongoing need for cleanups. And this is also a way to engage the public, as we all know, and increase stewardship of our public and our citizens and our businesses to try to engage in what's important to clean our waterways and get clean water. And then lastly, and I think this is a super important point, is that these regulations are the pipe network that drains to waterways. Stormwater is regulated through the MS4s. There's a lot of direct dumping into local waterways. Homeless encampments, unsheltered communities is a growing problem. I think California has about half of all homeless unsheltered folks in the nation. So in California in particular, because of our climate, and housing issues and prices, we see an increasing homeless aspect to this, and so there's impacts associated with those societal issues as well. So this is my last slide. There's a link down here at the bottom to this image. I get asked for this image a lot, that shows sources and pathways of trash to local waterways, and so that link right there is your way to get a hold of this image without having to contact me. So with that, I'll stop sharing and pass it over to Michael.
Yes, thanks, Chris. I'll start up my presentation now. Thanks, Chris. You actually covered a lot of my background, so I can rush through that as we get into it. So yeah, I'm Mike Hanna. I'm the technical director from Enviropod, and I'm going to talk about some of the lessons we've learned in developing our premier product, the Enviropod litter trap. We're a specialist catch basin technology company. Yeah, we're new to many people in the USA. We've actually been around for 25 years. That's a picture of me in the center there, back at the end of the 80s, sporting an afro and some flares. We're based in New Zealand, and New Zealand's in the middle of the Pacific Ocean, so we care quite greatly about the ocean and our waterways. We are a specialist stormwater company. Well, Enviropod's part of the Stormwater 360 group, which is a specialist stormwater company that deals with underground filters, green roofs, bioretention systems, and we really believe in science and innovation to tackle stormwater issues. So we've got our technology installed obviously across New Zealand and Australia. About 4 years ago, we set up in Canada, and in this year we partnered with Clean Waters USA, and we're distributing our technologies across the USA. So what is trash? And the definition was put in there by Chris just before me, but essentially it's an improperly discarded waste material from human activities. And the picture down in the bottom left here, I'll just turn my pointer on. Here is the type of material we find in the traps. It's plastic packaging material, it's containers, plastic drinking containers, it's cigarette butts, and that makes its way into the ocean, where it actually floats, and is often, most of it's actually neutrally buoyant. Some settles, but some floats on the surface, but some floats in the water column. And this picture down here shows as a picture of Bali with the trash floating in the water column. The video at the top is showing the trash and material taken out of the stomach of a turtle that's been found dead, or not dead, saved off the coast of New Zealand. And the resemblance between what we find in the trash traps and what we're finding in the stomachs of turtles is remarkably similar. And there's 1 million sea mammals, ocean mammals, dying each year. And that's really my driver and why I'm so passionate about trying to stop plastic and gross pollutants. Because if we can't stop plastic and gross pollutants, what hope do we really have for more of the nastier stormwater contaminants, such as zinc and phosphorus and nitrogen and things like that? So no talk on trash really cannot consider gross pollution. Down under, we've been tackling gross pollution since the 90s. And actually the definition around 5 millimeters came out of work out of Australia in the 90s. It was pretty much chosen as a cutoff point for large debris. And gross pollutant is everything over 5 millimeters from where I come from. So it is organic material, it's bits of wood, it's coarse sediments, and of course it's trash and plastic. Between 50 and 90% of gross pollutants is organic material, and that actually takes up the bulk of the weight and the mass. And that can be quite significant in what's coming down the stormwater pipe and ending up inside your traps. On a mass basis, we look at between 80 to 320 pounds per acre of load mass of gross pollutants coming down the pipe. And because actually this material, organic material and plastics, is quite light and not very dense, it actually makes quite a large volume of material. And you really need to consider that in sizing your traps, because it can be between 6 and 30 cubic feet per acre of material coming down your stormwater trap. Gross, that's material over 5 millimeters. So Chris touched on this. There's a range of techniques. There's true source control, i.e. ban the bag. And as I put these pictures like this, because it's a bit of a cascade or a steps down. You start with trying to ban, obviously, get rid of the problem, the plastics and that we're being discarded. But then we can move to like source controls, such as sweeping and education. At source controls, which I like to define is actually interventions at the catch basin, the interface between the stormwater network and the actual source. And so that provides a real opportunity. And then we have inline and end-of-line screening devices or vortex screening devices. And lastly is obviously trying to clean it up in the ocean or off the beaches. And then there's a few people trying to do that. Bonyan Slap from Belgium, I think he's from, is trying to clean up the Great Pacific Garbage Patch. So yeah, I'm going to focus on at-source controls or catch basin controls because that's kind of what we do and we specialize in. But it's also in the setting up of these trash regulations across the USA, and the very first one, the Los Angeles River Watershed TMDL, they did an analysis of the cost effectiveness of different types of full catcher devices, and at-source interventions or catch basin interventions had an equal cost effectiveness as large end-of-line GPTs or gross pollutant traps or high flow screening devices. What wasn't so good was the inline or low capacity systems, because you needed quite a lot of them. They're quite expensive and it takes quite a bit to excavate and install them. So what is a catch basin insert? Well, essentially it's an intervention that can be installed in a new or existing catch basin. It enhances the water quality of that catch basin. It's not necessarily just the insert that's doing it, it's the interaction between the catch basin and the technology being placed in it. It doesn't require any construction, so that really lowers the capital cost, and it makes it really easy for people to get in and implement these systems. But it does require ongoing maintenance, and its location at the entrance to the stormwater network means it's actually quite critical that that maintenance happens, because we don't want to cause flooding and we don't want to destroy public property or even endanger lives. So the other reason why at-source interventions are really good is because you can actually target the sources of litter. And that's again why I call it at source. You can target the areas of high human activity where you're likely to have high trash generation, either industries and factories or outside shops and cafes. You can actually go out and target these areas for interventions rather than trying to capture everything from a whole catchment. And we've done quite a bit of work on identifying what we call these trash hotspots. And we find, obviously commercial areas have the most amount of trash, this picture on the right. And also this picture shows the area in red is actually the plastic component. And it's roughly between 60 to 80% is what we're finding, which ties in nicely with what they're finding in California and Chris's work. But it is highly variable as we move around. And we also find that areas like schools or reserves, public recreation areas also have quite a high trash loading, but it's often very seasonal depending on when people are actually using those facilities. So I'm now going to kind of quickly move on to the critical factors in designing a catch basin screen. As I said, I'm a civil engineer, so I'm quite technical on how the hydraulics work of these things. And so I'm just going to quickly skim through this. So firstly, well, what is a catch basin, or what's the catch basin characteristics? Because your catch basin insert is going to be fitted into these things, that's going to influence the performance, as I've said. It's going to limit the performance or limit what you can put in. And the issue is that there's no two catch basins the same. Basically, catch basins have been around since the Romans, and they come in all shapes and sizes across the world. And they've been principally designed to get the water away and stop flooding, not to have something put in to capture trash or improve its water quality performance. So that's quite a challenge when you come to try to put something in. So any device that goes in these things have to be really flexible to accommodate that variability in shape and size. And also the key thing is that shape and size of the catch basin will really dictate the performance that you can get, like how much water you can pass through your device. If it's a bigger catch basin, you can put a bigger device in, such you can pass more water. Another key factor is what the type of screening mechanism. There's indirect or direct screening. Essentially, indirect screening was where the water flow is at 90 degrees or to the screen, and this allows some sort of self-cleaning. Now, I've got a couple of photos of different types of catch basin inserts that employ different types of screening mechanisms. The pictures at the bottom show more direct screening, where the water flows straight into the screen and then out to the outlet, and that sets up the ability for the screen to clog or blind, as you can see in these two photos at the bottom. On the top is a basket or a box type screening device, and the water actually flows down over the walls of the basket as it falls into the base, creating some sort of self-cleaning. And you can see the area on the top is clean, and the trash is stored at the bottom. Another critical factor is just actually the screen loading rate. How much water are you passing through that screen per inch of screen? And the smaller the screen, essentially, the more water is going to be passing through, the higher the velocities are on that screen, and that's more likely that it's going to clog as a particle is jammed into that screen. We also need to really consider the head loss of those screens, and a head loss is quite critical in a screen, because that's really how much the water will well up in front of the screen before it passes through the screen. And a low head loss fabric will allow you to pass more water. It gives you more capacity to well the water up, where a high head loss screen will tend to well up and go into bypass quicker than a low head loss screen. So how do we measure head loss? And Seth at the start did introduce the new ASTM stormwater control trash capture testing protocol. I'm part of that committee working on that new protocol. But essentially, head loss is the difference between the downstream level of the water and the upstream level of the water, upstream of the screen. And that can be quite easily tested and evaluated in the laboratory. It's also very important to consider what are the head loss factors? And it's not necessarily how big the holes are. Here's a little example. We have two screens. The B has bigger holes than screen A, but screen A has more open area and more of a uniform shape. And this graph on the right shows the head losses, where screen B had a much greater head loss than screen A. It's also noted that as flow rate goes up, head losses tend to elevate as well, because it is a function of flow and velocity. Next is probably the most critical factor in any sort of catch basin insert. With it being installed at the entrance of the network, we can't have it clogging and blocking, and at higher flows, big 1 in 10, 1 in 20, 1 in 100 year events may need to pass around the system. So you need to, all catch basin inserts need to have some sort of bypass mechanism, and they're pretty much either an orifice or a weir, and that will dictate how much the water is going to well up above that orifice as well. The length of that weir or the cross-sectional area of the orifice will dictate how much water it can go through. Also, how far down in the device in the catch basin it's stored is also going to influence, because that's the amount of driving head that can be push through. It's also really important to make sure that once the water has gone through in the bypass, that it doesn't block up as it goes towards the outlet. And on the right here, I've just got a couple of different pictures of different bypasses. This basket system here has quite a large slot at the top. This is a bypass in the center, quite a small little hole. And the one on the bottom here has a more of a weir type bypass, but it's fouling with large gross pollutants as it's going through the bypass. Next critical factor is the pollutant storage and where the pollutants are stored, because that actually impacts the flow rate through the device. As the pollutants are stored within the device, they tend to block up the screen, as you can see here, and that gives you less available screen area and less driving head to pass the water through. So to manage this, obviously the bigger the catch basin, the bigger the treatment device you can put in, and therefore the more storage volume you can have. But also it's really important to consider the flow rates through that screen as the device fills up. And actually to get in part of the certification process with the California Water Board, you need to show your flow rate at different levels of full inside the catch basin. So lastly, and probably the most critical thing is maintenance. I've got, there's really two methods of maintaining catch basins inserts, either by hand or by vector truck, but it really comes down to a simple case of economics. A vector truck costs roughly $350 an hour. It's nice and quick to maintain a device, but if a device can be maintained by hand, 2 people and a pickup truck is roughly about $600 a day. So if you can get around and maintain your catch basin insert or your trash control device by hand, it's going to significantly save you money. Obviously, too, good access, as these 2 videos are showing, is really critical to be able to maintain a device. And you also need to consider, you might need to remove the device and clean the screen sometimes, because it might clog up and blind with all that organic material coming through. So quickly, just to summarize, so trash is a different kind of pollutant to other stormwater pollutants. Trash traps have can trap large volumes of trash, but also organics. At-source treatments can be a very cost-effective way to manage trash in urban areas, and that's largely through hotspot targeting. You don't need to put a trap in every catch basin to get a large capture of gross pollutants or trash. The critical factors when you come to designing a catch basin insert is the type of screening mechanism, whether it's direct or indirect, because that affects clogging. Your hydraulic loading rate also affects clogging. Your head loss and your bypass are critical for how much water can go through the device without causing flooding. And lastly, maintenance. Where your pollutants are stored and how you're maintaining it is really the biggest cost factor when you're looking at these treatment devices. So that's me. I'll hand it back over to you now, moderator.
Fantastic. That does wrap up our time for today's webinar. So on behalf of Stormwater Solutions and our sponsor of today's Lunch and Learn, I would like to thank everyone for their participation. Stay tuned for additional events. We hope you stay informed and stay well.
Thank you.